So today we're going to tackle the derivative shortcut rules for trig functions. First thing though, we will need to kind of take a diversion and talk about limits of trig functions. We're going to need these limits in order to talk about the derivative formulas. And so some limits of trig functions can be evaluated by continuity. So for example, if I were to give you the limit as h goes to 0 of sine of h over 1 plus cosine of h, first thing you should do when you see a strange limit like this is sneak a peek. And what you'll find is that you get 0 over some non-zero number. So in this case, the limit laws do apply, or you could make an argument to continuity. Sine and cosine are continuous everywhere on negative infinity. This particular denominator can never be 0. So you could essentially just evaluate the limit by setting it equal to the value of the function. So by continuity, this is going to be the sine of 0, 1 plus the cosine of 0, which does in fact give you a 0. Now we could have used the limit laws and just evaluated it directly, but the point is the same. This limit has no issues. A limit like this, on the other hand, does give us headache. Now this is an important limit. It does give us a 0 over 0. So that means no limit laws can apply, and we've got to do some sort of algebra. Now, unfortunately, it isn't an algebra issue that's going to save us here. We actually need to go in some way one level down. We need to go to geometry. Now, I'm going to refer you to the textbook for a proof of this. You're going to talk about areas and you're going to compare them. And at some point, you'll end up using the squeeze theorem to evaluate this limit. So it is possible to get a value of this limit, but for our purposes, we are going to cheat a little bit and just talk about the graph of this function. So it will turn out that you can graph this function, and it has a picture that kind of looks like this. The one important thing is that there's a hole right at 0. But if we are interested in the limit as h approaches 0, sine h over h, and we take note that this is a two-sided limit, it turns out that this limit will go to 1. And I put a box around this because it's going to be a very, very useful limit in this course and in other places in math, if you continue your math education on. So the limit of sine h over h is equal to 1. Now, what's really important is that when you concern yourself with this limit, the letter h itself is not important. It just acts as a placeholder. All three of the things in this box have to be the same, whatever that is. So it could be an h, it could be an x, it could be a theta, it could be a smiley face, it could be any combination of things. As long as it's the same, this limit will exist. So our goal is to try and write limits in terms of sine h over h, and then use the above limit. So this is very much like when we talked about limits at infinity. We tried to write everything in terms of 1 over x because we knew that that limit existed. So for example, if we were to say something like the limit as t approaches 0, sine squared of 3t divided by t squared. First thing we do is sneak a peek. As always, we cannot just directly apply the limit laws. We are going to try to write this in terms of some sort of sine blank over blank. And there's a question mark there, right? What should that blank be? In this particular case, because I've been given a 3t, we'll try to write everything in terms of sine of 3t divided by 3t. That's going to be the bundle that we're trying to incorporate here. We're going to identify this limit as the sine of 3t multiplied with the sine of 3t. Remember, this 3t is a bundle within the sine. And downstairs, we'll recognize the t squared as t and t. So we are very close. We've got the sine of 3t over t. Now, in order for this limit to truly work, we would really love it if there was a 3 here to match with this bundle out front. I don't have one in the bottom, but I can put one there as long as I put another one upstairs to balance it. And the same is true over here. If I really want a 3t downstairs to match with this one, I've got to make sure I put another one upstairs. Could I now use the limit laws? Because it looks like I've got this bundle sine of something over itself. There's one very subtle point. As t goes to 0, it's also the case that 3t goes to 0. The limit as t goes to 0 of sine of 3t over 3t, I could interpret this as really the limit of 3t going to 0, sine of 3t over 3t. And what's important here is that all of these match, and this does in fact give me a 1. So I can use the limit laws, and it will all work out quite nicely here. So I'll end up with a 3 times the limit, t goes to 0, sine 3t over 3t, another 3, limit t goes to 0, sine 3t over 3t. It will turn out that these limits do in fact give me a 1. So this limit equals 9. So that's the strategy in an example or in a situation like this. We are trying to take a strange limit, and when we see that it has trig functions, we are going to try to write it in terms of sine h over h. This is another example of a trig function, and I'm taking its limit. Now, you should sneak a peek, and you should find that it's 0 over 0. And as always, no limit laws here. And the fix for all the limits in this section is algebra, and we are going to try to write everything here in terms of sine h over h. That's what I'm supposed to do, but how am I supposed to do it? We've got cosine of h minus 1 over h. Now, just like before when we talked about roots and we talked about conjugates, there's going to be another conjugate idea appearing here as well. Except the conjugate isn't going to involve roots. It's going to be a conjugate of the upstairs. So upstairs, I'm going to multiply this expression by the cosine of h plus 1 divided by itself. So if you look at the top, it's going to end up giving me cosine squared of h subtract 1. And I'm just going to leave the bottom factored as it is. So that's really a non-issue there. That sine squared of h plus cos squared of h is equal to 1. And so that means if I ever end up with cos squared of h minus 1, it's negative sine squared. Remember, the entire goal of this strategy was to get everything that's present in terms of sine h over h. And this is my really sneaky way of doing that, because I've finally introduced a sine. I'm going to take one of the sines from upstairs and write it divided by the h in the other side. And then I'm going to take this thing that is downstairs. And if I look at this limit in this particular sense, and I ask can the limit laws apply? I'm hoping you can see by this point that the answer should be yes. I know that this exists, this particular limit, and it goes to 1. Now, upstairs from earlier, I went through and I evaluated this limit. This one exists as well. This turns out to give me a 0. So yes, I can now apply the limit laws. I'll have a negative limit h goes to 0 sine h over h times a limit h goes to 0 of this business that we talked about earlier today. And as you can see, the limits can be evaluated and I end up getting a 0. So I'm going to make note of this result that we've got. Cosine of h minus 1 over h, this limit gives me a 0. I'm going to put a little bubble around it because we're going to need it in the next video. Other than that, this is the process by which we'll use to evaluate trig limits. In this section,